All right, let's talk about your password's worst nightmare. And no, it's not password 123. This sounds like something straight out of science fiction, but the threat is very, very real, and it's called quantum computing.
So let's just start with a huge question. What if the very thing that protects everything, from your bank account to your DMs to top secret government files, what if that unbreakable lock is about to be picked by a key that we've never seen before?
To really get the threat, first we have to appreciate the incredible defenses we've already built. I want you to think of our entire digital world as this massive global fortress. The walls of this fortress, they're built from something called encryption. And you can kind of think of it like two different kinds of locks. One is like a public mailbox. Anyone can drop a message in, but only you have the key to open it. The other is more like a secret lockbox, where you and your friend have the exact same key to lock and unlock it. Both are absolutely crucial for keeping our data safe.
And you rely on this fortress every single day, probably without even thinking about it. You see that little padlock in your browser? That's encryption. When you buy something online, send a private message, sign a digital document, yep, it's all being protected by these super powerful mathematical locks.
So why are these locks so strong? Well, they're built on math problems that are just ridiculously hard for our current computers to solve. I mean, we're talking about problems that would take the world's fastest supercomputer literally billions of years to crack. That right there is the foundation of all of our digital security.
For decades, that fortress has been totally secure, unbreachable. But there's a new kind of challenger on the horizon, one that doesn't play by the same rules at all. This is the quantum threat.
Okay, here's the key difference, and it's a bit of a mind bender. Your phone, your laptop, they use bits. They're like simple light switches, either a 0 or a 1, off or on. But a quantum computer uses qubits, and a qubit can be a 0, a 1, or, and this is the wild part, both at the same time. This means it can explore a mind-boggling number of possibilities all at once.
But it's not just about raw speed or trying more keys at once. It's about having a fundamentally different kind of key. Quantum computers have a secret weapon. They run specialized algorithms that are specifically designed to crack the very math problems our digital fortress is built on.
In the quantum arsenal, there are two main weapons you need to know about. First up is Shor's algorithm. This is the big one. It's a catastrophic threat to the encryption that protects our websites and digital signatures. Then you've got Grover's algorithm, which is a significant threat to our other types of encryption. Not quite as bad, but still a huge problem.
Now look, this is not some distant, theoretical problem for physicists to debate in a lab. The existence of these algorithms has kicked off a very real, very urgent, high-stakes race against time.
This quote right here gets to the absolute heart of why this is so urgent. The danger isn't just in some far-off future when a powerful quantum computer is built. The threat is happening right now, and it's called harvest now, decrypt later.
So let's walk through what that actually means. Right now, today, adversaries are scooping up and storing massive amounts of our encrypted data. They can't read it yet, but they're just holding on to it, waiting for that near future when a quantum computer comes online that's powerful enough to break the encryption. And then, all of today's secrets, our private messages, our financial data, our national security files, they become an open book.
Okay, I know that sounds pretty terrifying, but here's the good news. The world's best cryptographers, they saw this coming from a mile away. They're not just sitting around. They're actively building new quantum-proof shields.
And the official name for these new defenses is Post-Quantum Cryptography, or PQC. The goal here is pretty simple, really. Create a new generation of locks that are based on totally different math problems. Problems that are hard for both our current computers and future quantum computers to solve.
And what's really smart about this is that we aren't just betting on one new kind of lock. Researchers are developing a whole portfolio of different strategies. They're using totally different kinds of math, like the complex geometry of lattices or the logic of coding theory, just to make sure we have multiple, robust lines of defense, no single point of failure.
And this isn't just theoretical research. This has been a full-blown global effort. The U.S. National Institute of Standards and Technology, that's NIST, ran this multi-year competition to find and standardize the absolute best of these new PQC algorithms.
And we have our first winners. Now, the names might sound a little strange, but Crystals Kyber and Crystals Dilithium are two of the algorithms that have officially been chosen to become the new gold standard for protecting our digital world in the quantum era.
So, new shields are being forged, which is fantastic, but the work doesn't just stop with one big upgrade. The real challenge now is securing our digital future for the long haul.
This whole scare has taught us a hugely important lesson, and it's a principle called cryptographic agility. Basically, we can't build systems anymore where one type of encryption is hard-coded in for decades. Our future digital infrastructure has to be flexible, designed so we can quickly and easily swap out old algorithms for new ones the second a new threat appears. And we absolutely have to get this right because the stakes just could not be higher. This is about so much more than your social media password. We're talking about protecting our power grids, our financial systems, our national security, the entire fabric of our modern digital world.
So here's where we stand. An invisible but absolutely fundamental upgrade to our digital fortress is underway. It's a massive, complex transition, but it's already happening. Which leaves us with one final, pretty big question. Our defenses are being rebuilt for a brand new era. So, are we ready?